NIFA project on a quantitative approach for recovering legacy P while minimizing nutrient deficiency risk. We are looking at a plot which is the control, that is the area where the P mining is supposed to take place, so there is no fertilizer that's applied. And just adjacent to me is another plot where the crops are grown with fertilizer application. As you may notice, there is a lot of difference between the two just visually. That is the one where you have the P being mined, the corn is much shorter and more yellowish than the one on where the phosphorus has been applied, suggesting that the corn now needs to be fertilized after repeated removal of the P by the cropping systems. The quantitative approach makes use of the soil P storage capacity approach, originally developed in Florida just over 10 years ago. The concept, referred to as SPSC, is calculated from phosphorus, iron, and aluminum in a soil test solution such as a Mehlich-3 solution, and is expected to identify sites where P application is needed for plant growth and when P can be mined by the crop. This is one of the 3 sites of the project located at the plant science unit where the soil order is anti-salts. The P is removed by a rotation, rye, silage corn, and sorghum. We looked at the silage corn rotation during year 1, and we did notice slight differences, visual observations between the P applied and the non-P applied plots. However, there were neither yield nor tissue P differences in the 2 different cropping systems. In other words, it looks like P mining has not created a problem. The soil P storage capacity keeps diminishing with repeated cropping cycles in the P mining areas, which is to be expected because the P is removed from the soil, but there is still sufficient P at the end of year 1 for further P mining, that is at the end of the first rotation of rye, silage corn, and sorghum. We will be monitoring SPSC after this corn cycle here in both the P applied and the no P applied plots, and the observation we expect is that the SPSC will be further diminished, and perhaps the differences in yield between the 2 cropping patterns or 2 cropping treatments would be different at that time, with the yield being decreased in the no phosphorus plots, and additional phosphorus may need to be applied. Now, we have 2 other plots or 2 other sites where identical experiments are going on. One is located at the beef research unit, and those plots are located on spodosalts. The third one is in the Panhandle region of Florida, where the soils are altisalts. At all the 3 locations, results indicate that SPSC can be used as a tool for P fertilizer application on a site-specific basis rather than a generalized soil test P value for a given cropping system. The SPSC approach will therefore increase the efficiency of fertilizer application for plant P uptake, reducing excess fertilizer application, and while at the same time mitigating legacy phosphorus.